Hi everyone, Mr. Morrissey. Today our objective is to solve quadratic inequalities, or possibly if we have a system, meaning maybe like a parabola and a line, or um, two or more equations, or inequalities I should say, would be doing that algebraically or graphically. And a couple things to make sure you know is that when you're graphing, if it is greater than or equal to, you have a solid line, and it says here make sure you use a dotted line for less than or greater than. There's the whole thing about shading. We'll do that. We've done this before, but shading, doing a test point and looking for true statements and false statements. Um, we can use a sign chart. I think we'll do on the last problem, but you can do sign charts to solve these. So you have a bunch of ways to do these problems. When you divide by a negative, when you divide or multiply by a negative number, you have to switch the sign of the inequality. And that's about it. Why don't we get right to this and take a look at example one. Please make sure you read over my notes and see, maybe read them over before we do the problems and maybe after to see if things are more clear. Okay, the first one is saying x squared minus 11x is greater than or equal to negative 28. So let's see. Whoops, let's turn this to a pen. Hold on. So x squared, we want to know when that quadratic, when the y values are greater than or equal to 0. So let's factor. Here's my quadratic. It looks like the roots are positive 4, positive 7. So let's do a rough sketch. Y-intercept's 28. Okay, so this is asking um, when are the y values greater than or equal to 0? Well, I'm going to highlight on the graph when that happens. So here and here, the y values are greater than or equal to 0. So in terms of the actual solution that you'd write, it's going to be when x is greater than or equal to 7 and x is less than or equal to 4. If you wanted to do the critical sign chart, so let's actually do the critical sign chart. So if we wanted to do it a second way, if you wanted to do the critical sign chart, there's going to be two critical points, 4 and 7. You know at 4 and 7, you know those are zeros, so you know the value of the inequality is 0. And then you want to test a point less than 4, a point between 4 and 7, and a point greater than 7. So let's do if x equals 0. If x equals 0, we're going to get 28. Well, 28 is positive, so that's positive in that interval. If x equals 5, x equals 5. Well, I can't plug, if I plug 5 into the standard form equation, it's going to be really hard math. But if I do 5 minus 4 and 5 minus 7, I can see that that's 1 times negative 2. That's negative. So in between 4 and 7 is negative, and that sort of corresponds to the graph. This negative value corresponds to the blue that between 4 and 7 that is negative. And let's just for good measure do 10. So 10 minus 4, 10 minus 7, that's a positive, and a positive, that's a positive. So you could see from the sign chart, you could see that the values that are greater than or equal to 0 are between, or not between, are, I'm going to put it on the graph, here and here. Okay, let's go to number 2. Okay, number 2. So number 2 says x squared minus 7x plus 4 is less than 5x minus 2. So let's rewrite this. So unfortunately, this one cannot be factored easily. So we're going to need to use the quadratic formula to figure this out. So we're going to get 144 minus 120. No, sorry, 144 minus 24 is 120. So let's see if that radical 120 can be simplified. I believe it can be. So I don't know the answer off the top of my head. I'm finding all the prime factors of 120. So let's see, I'm almost done here. Whoa, sorry. So it looks like we have 2 times 2 times 2 times 3 times 5. So it looks like 2 root 30. 2 root 30. So 2 plus or minus 2 root 30 over 2. Okay, so those are the two roots, and I want you to know how to estimate whether or not those roots are positive or negative. So you know 6 plus root 30, you know that's a positive number. So I'm just going to throw that on the graph. Now the question is if 6 minus root 30 is going to be positive or negative. So is it going to be to the left of the origin or to the right of the origin? Well, 6 is the same thing as root 36. So root 36 minus root 30, root 36 is greater than root 30, so that's a positive. So we'll put a dot here. I don't know exactly where, precisely where it is, but I know it's going to be a positive. And here's a rough sketch of the graph. And the y-intercept is 6. So when is that graph less than 0? It's going to be less than 0 between, let's highlight it, between those 2 points. So let's write it down, and we'll be done. So the answer, oh, I noticed this should be a dotted line because it's less than or greater than. So we have a dotted line, we have the two roots, and the answer is, here we go. So the answer is 6 minus root 30 is less than x is less than 6 plus root 30. Estimating those radicals is a good skill to know how to do. All right, guys, let's go to the next one. Okay, here's the system of inequalities. Let's graph, being careful to realize this is a solid line and this is a dotted line. So y is less than x minus 4. Let's graph that one first because I'm a little more confident with a line. That's older material. The slope is 1, positive 1. Okay, so let's make sure this one's a dotted line. Okay, and so now let's do a test point. Let's test 0, 0. So test 0, comma 0. Is that a true statement? It's not true. That is completely false. So we are going to shade away from the false statement. So let's shade down here. Okay. Is it killing some people that I didn't fill in all the little shading areas? But now let's put in the parabola. So now the parabola, part 2. The parabola is going to be a dotted line. The y-intercepts are 4 and negative 4. So we're going to be centered at the origin, and the y-intercept is -16, so it's way, way down. So this is going to be a rough sketch, okay? So there's the parabola, and now we want to do the test point. So I'm going to suggest testing 0, 0. So let's test 0, 0, okay? So is that true? That is a true statement. So since it's true, you're going to highlight, you're going to shade all the area that includes 0, 0. So this is true. So let's shade all of the area that includes 0, 0. So the actual answer for this is the part that has green and yellow. So it's going to be all this area in here, this little sliver. I have a dotted line for the line, and I have a solid line for the parabola, and it looks good. All right, we got two more tough problems here. Um, let's see, let's look at this next one. Find all real values of y such that blah, blah, blah. Okay. Um, this one, let's see if we can find the most direct way of doing this problem. So we're trying to figure out -x squared plus 10x minus 30 when it's greater than or equal to 0. I know this is going to be an upside down graph. So no matter what, the graph's going to look maybe like this, something, it'll be upside down because of that coefficient in front of x squared. Now, we could complete the square to figure out what the vertex is. I'm going to suggest to review an old concept. The vertex is negative b over 2a. So let's figure out what the x-coordinate of the vertex is using negative b over 2a. So a is -1, b is 10, c is -30. So I got to move over. There's a dead zone in the board here. So let's see. X equals -10. Looks like 5. So 5 looks like the x-coordinate um, of the vertex. So now I get to figure out what the y-coordinate is. So I'm going to plug in 5. So plug in 5. So okay. Make sure you know that 5 squared times -1 is -25 and not +25. You have to follow the order of operations. Okay, so let's see what this becomes. So what would be easier? So this is going to be 25 minus 30, so -5. It would appear that the vertex is 5, -5, and it opens down. So if the vertex is 5, -5, and the graph opens down, and you want to know when the graph's y values are greater than 0, there's no values um, above the y-axis. So no solution. You want to know when that graph's y values are greater than 0, and there are none. There's not one time when the y values are above the x-axis. Okay, last one. Find all values of, oh gosh, this is a cubic. This, we won't have to graph. This one we're going to do a critical points, because we're not going to be graphing cubics until the next unit. So we're going to do a critical points test. So critical points. The first thing I'm going to do here is I can notice that you can factor out an x. So let's see. There's part 1. Okay, so here is my um, factored cubic in x minus 3 times x minus 3 times x. Now, coincidentally, we're going to learn that the x minus 3, you guys know, is a double root, and x is a single root. So the graph is actually going to look like this, okay? But we're doing that in the future. For right now, this is going to be a great problem to do a critical points test. So let's see if you can see the relationship between the graph and the critical point. So here's 0, here's 3. I want to test some points. All I want to do is test some points between 0 and 1 point between 0 and 3, a point greater than 3, and a point less than 0. So let's do 10. So that's 3 positives multiplied together, so that's a positive. So the values that are greater than 3 are positive. Let's test 2. That's a positive, a negative, and a negative. Well, that equals a positive as well because the two negatives cancel. And you can see that on the graph between 0 and 3. Look back at the graph. Between 0 and 3, the points on the y-axis are above the x-axis. And let's test one more, negative 1. So this is going to be a negative, a negative, and a negative. 3 negatives are negative. That means the graph less than 0 is negative. So doing that critical points test, which was referenced at the beginning of the notes, if you look back at the notes and reread the notes, um, the question is asking, when is the graph less than 0 or equal to 0? Let me go back up and show you. Right here, when is it less than 0 or equal to 0? So the graph is going to be less than 0 here and also at 3. And that's something that people often miss. So the answer is x is less than or equal to 0, x equals 3. 好吧？行，行不行？行. Okay, so let me just make sure. Yeah, less than or equal to 0, perfect. So look, and I put on the graph. Here, all the y values are less than or equal to 0, and right there at 3, the y is equal to 0. All right, guys, that was a lot of graphing, but we're going to be confident with our graphing. We're going to find x-intercepts. We're going to find y-intercepts, do test points, possibly do a critical points test, and good job. Thanks a lot. See ya.